So this, just to remind you in terms of what we did on Friday with this problem. Remember the Jello bowl?
Oh yeah. More likely messed up.
What was the big takeaway from that?
Don't make sure you have your dy dt.
Yeah. Yep. So whatever you're taking the derivative with respect to, make sure that you do the implicit part of that for each term. Yeah, good job. So just wanted to use this applet, I guess it's called, to kind of demonstrate, just to remind us what we're doing. So this is x squared is our black line, and then the red line is just 2, x equals 2. And so it kind of, I wonder if I can zoom this. It's a little better. So you can see as we rotate it around, this is what we're doing. It's a lot better than being able to draw it. And yeah. Okay, and then if we change the view a little bit, which is really hard with this pen. I'm use the mouse. Don't look, you'll get sick. That helps a little. Does that work for you guys? Okay, so here's the shape we're making. It's kind of that trumpet bell shape. Okay. Mm-hmm.
It's kind of crazy we just introduced the third dimension into math like so casually.
I know, right?
I don't think I've ever done math in the third dimension until just now.
Not like this. That's true.
It's like, oh, now we're going to rotate.
To have a z-axis. Yeah. Okay. So again, I'll put this on the link and you can play around with different functions. This one's nice because you can change the function that we're using to make the shape, whereas the other one was just set as that kind of weird x squared and root x1. So far we've taken like this one was relative to which axis, the circles? That one was relative to y. We were given the function rule in x, but then it was relative to y. And we've done x. And that was a pretty critical part of the reading, right? To make sure you read which one to take it relative to. So now we're going to just move the axis around a little bit. Same process, but just adding the twist of where we're taking or what line we're taking the sections relative to. So what is the volume of a solid in terms of revolution? In fact, I'm going to add that to this solid of revolution. You guys remember what goes in here?
Yeah, it's going to be pi r of x.
Yeah. What is r of x? Right. Yeah, whatever function that we are using for the radius of the circle. So this is still disks, and then tomorrow we'll jump into washers, and we'll do 2 on washers, and then that's the end for us. We'll see going through our review, so we'll be able to start review Thursday probably. Well, we'll see. Maybe next week we'll hit the review. And you guys are here? Are you here throughout April?
Yeah, other than the 21st.
21st, Monday.
Are we back? Till after the test, the Christians on its own.
Wait, what's the last day? What's the last day of school?
21st.
21st. Because 22nd. Yeah. Wait, so what are you guys going to do?
After the test? Well, I don't know. I mean,
So
somebody
much
was
fun
saying that
eventually.
he may not come, or he's going to be in the park, you know.
Oh, yeah.
Kid's going to be in the park.
No, it was you. You were saying last year he was saying like you don't have to come. I don't know. I have some projects that we can apply this to. It would be fun if you want. Like we'll just talk.
We'll just have a
Yeah.
Do you want to go on that?
Like some ways to apply the stuff we've learned.
I've done 2 years of calculus. 5 days longer than me.
That's kind of like what Mrs. Yost did. Like took the test and then we did like a project.
Yeah. All right. So this first one, revolve about the line y equals 2. Where is that line? So we should sketch this a little bit.
It's like up to.
Okay. I would recommend when you do these, sketch first, Just gives you kind of an idea of what you're looking at. So where is the y equals 3 minus x squared? What does it look like?
It's a concave
Down parabola.
that's up 3.
Yeah. Okay, and then our line y equals 2 is just a horizontal line. Yeah, I agree. Okay. I don't know if you want to sketch the rest of it. Like, I don't know. Maybe I will. Something like that, right? Once it's rotated. So same strategy. We're going to do disks. How do we know which axis to, like which direction the radius is going? Like, is it horizontal or vertical? Is what I'm asking.
It's vertical. This is perpendicular to
Okay.
the.
So do
Rotating arm.
Yeah.
do our slices this way?
Yeah.
Okay. And so why did you say that?
It's like I don't know how simple words. It's like
Okay. It's
perpendicular to what we revolve.
okay. Good. There you go. So perpendicular. Take cross sections. Do you guys remember the geometry symbol for perpendicular?
Yeah.
Yeah.
All right. So how do we set this up? V equals
For negative 1 to 1. I.
what did you say here?
Negative 1 to 1.
And how did you get that?
It was like
Because it's a regular
it
parabola.
was like one down.
Yeah.
And one across. It just tells it like down.
Basic knowledge of parabolas.
Good job. All right. So and then what's our radius going to be?
It's gonna be our parabola minus 2.
Yeah. 3 minus x squared minus 2 whole thing squared. Why is it squared?
Because it's the formula for a circle.
Good. Area of a circle. All right. So you said basic knowledge of parabola. What could you do if you weren't sure? Yeah. Okay. Any questions on that one? Oh, you know what? That reminds me. Remind me at the end. Let's go back and talk about a problem from before. We didn't do it wrong. I want to talk about a second strategy that we can do on there. All right, number 2. Revolving now about the line x equals 1. So let's notice first that this is written in terms of y. So we need to know what shape x equals 2 minus y squared is.
Slightly around.
Yeah. Which way does it open? Like this?
Yeah.
Or like that?
No,
First.
Good. Okay, what does the 2 do?
It's just up
Well, but what is up?
to the right.
There.
Well, I just turned my paper on. I just
Oh, okay. That's a good idea.
Christian knows more shortcuts, am I right?
I can't turn my screen, but I wish I could. And the line x equals 1. So do you see how this is going to basically be the same shape? Only it is so hard to draw through stuff when you have a shadow in the way. That's going to be good enough. Same shape, only rotated different direction. So this one's already set up and everything for y. So don't worry about that. What are our limits this time? Yep. And our radius?
1 minus x squared squared.
1 minus x squared?
It'd be 2 minus y squared minus 1. Or, sorry, 1 minus y squared.
Why are you doing... Oh, okay.
Maybe you simplify it.
Yeah. Gotcha. How would you integrate either of these?
You would distribute the, or you would elongate it, distribute it.
So let's go ahead and do the by hand integrals on both of these. And like you were saying, you can do that, but is there another way?
I mean, I guess you could do.
Use substitution.
Yeah. Let's see. Wave equals pull pi out front.
Yeah, but you're going to have a 2x in there. Are you doing u substitution?
Nope. No.
Okay. Because of that, right?
Yeah.
Because then you're going to get like...
Well, let's start with the second one.
Oh, you did? Okay. Let's just do the second one. But anyway, on the first one, since you're already working on it, on the first one you're going to get du over negative 2x, and then this would be u squared. So that's not going to... Huh? Okay. Is that right?
20/15.
So negative 3 plus 10 is 7 plus 15 should be 22/15. But why are we getting a negative volume?
Isn't the plus one supposed to be a minus one because of the negative? Because that's y, right?
Oh, minus.
Minus
Yeah.
one.
Minus. Oh, but I'm just doing it in here. I'm doing minus the whole thing.
Oh, I see what you're saying. So you did
So I did.
the first one. Okay.
Yeah, but that
I see.
should still be a negative one, no?
No.
But for what?
Well, because the integral. Oh, you're right. It should.
Now I'm getting 0 boundary.
Yeah, because that'll be negative 3 plus 10. Oh, I forgot to change that.
Negative 3 plus 10 minus 15 is negative 8.
But negative.
Oh.
Let's pause here and apply what you said from Saturday. Where could we have stopped?
At the interval. B equals integral of y.
No way. Well, because I guess it's not possible.
So let's sketch our picture for this. Okay, so 2 to the x minus 3, what does that look like?
It's an exponential growth.
Yep, but shifted down by 3. So where does it go through on the y-axis? Like what's the y-intercept?
Like a little bit bigger.
Well, but it's a number, it's
It's
2, negative 2.
Ah.
And then, remember, negative 3 becomes our horizontal asymptote. And we could solve for the x-intercept too if we wanted, but probably not. Okay, and then y equals negative 2 is there, and the line x equals 3 is there. Okay. So it's kind of like the one I showed you on the applet, in terms of its shape at least. And we're revolving it around the negative 2. So what are we going to take our sections relative to? X direction or y direction?
X. Yeah, it's going to be.
Good. So I would sketch in what it kind of looks like as a 3D. Best you can, at least.
That sounded like nails on the chalkboard.
I know, it's not annoying, huh? Okay, so something like that. Now be careful because, let me ask you this. If we go do, well, you tell me what you wrote for your radius.
2x minus 3 minus equals 2.
Okay. So remember that when we take an integral, like let's just leave this off
Yeah.
for now. What is it taking, like, between this curve and where is it going, is what I'm trying to say. Like, ignore the pink y equals -2 line. If we just did the integral of the purple exponential function, which way is it going? It's going back to the x, right? And in this case, -2 is actually further down.
Okay.
So, and it would, if we just did -2, of course, it would be between it and x also. So really, this needs to be reversed. Because the difference down here below the x-axis, the difference between the two would be -2 to the x-axis, and then our function would be above it, so to speak. Does that make sense?
Okay.
So we would do 2 minus?
-2 minus our function. Now, what would happen if you reversed it?
You get a negative volume. Or wait. Would it matter because you're squaring it? Because you're essentially just squaring the radius.
There we go. So does it change the final
No.
result in this case? Your face looks like.
Well, I'm trying to think of why we would have to flip it in the first place.
Well, just to be like, if we're representing what we're doing with the math inside of the integral, technically we want to subtract. Like in the other ones we've done, and I probably should have mentioned this, but like in this one, we're doing the pink parabola relative to x, take away the blue line relative to x. So if you flip this over, we have to make sure we're doing the further away from x as the bigger, right? And then subtract as the, quote, bigger number.
Because, like, normally, if we just took the integral of this function, it would be negative.
What would be negative?
Like, the integral of 2 to the x minus 3. would be
Yeah.
negative.
Okay, yes. Well, in that little region, like, it would be, if we did what you said, it would be filling in that little spot, right? Between it and x. At least up to wherever it crosses the x-axis. And that would be negative. And then it would flip to positive when it crosses. So, if we drew it bigger. So like this area would be negative, and then this area, wherever we stopped, would be positive. That's what you're saying, right?
Right, but since we're taking it from -2, I'm still, why are we looking at flip it?
Well, because if you're going from -2, you're subtracting all of the area from -2 to the x-axis, which deals with everything below the x-axis. So you're getting rid of that. And then
Yeah,
the one
let's-
up top.
Let's zoom in on that. So we have that, and so we are
So
taking all of this area,
getting rid of that.
and then, I don't know if this is helpful, but we're removing that area. I should have moved my 2 down over that, but we're removing that area.
Oh, that makes more sense.
I didn't do it very good on the zoom up, but
But so if we're removing that area, then how do we add the area above it? Because if we're subtracting the area that's bounded by the curve, then how do we add the area above it? Would we have to find separate spots at x equals, or like at the x-intercept?
are you saying this area like up here?
Yeah, it's like if we're subtracting the area that's bounded by that curve, then wouldn't that be subtracting that area rather than adding it?
From the perspective of the -2,
Oh, I guess it would be adding it because it would just be a double negative.
yeah,
Yeah.
that's what I was going to say too. Anyway, why don't you finish that problem and then do
Hannah Thompson, you're needed at attendance, please. Cadmer Thompson to attendant.
Just do the practice.
Thank you.
There's
Oh.
only 8 problems.
Okay.
And I forgot to ask you, did you guys do the?
I did the.
And how did it go?
It went pretty well.
I'm still working
Yeah.
on the FRQ portion, but I
Okay.
did the multiple choice.
Okay. And then did you do like him and like check as you went?
Yeah, it's so helpful when it's checked.
Okay, good. See, and how did you feel like it went?
I feel like I went good. It's just 'cause it's like it explains it to you and then you understand it. But then it's like, why didn't you do it first?
Don't you hate that feeling?
Yeah,
Oh my
it's like-
goodness.